Welcome to the IOTShield install and maintenance guide. In this video, I'll walk through how to set up the IOTShield lab from the code package, configure Splunk, run the 3 IoT simulators, and keep the environment maintained over time. First, a quick overview of what we're installing. IOTShield consists of 3 Python-based IoT device simulators, a Splunk Enterprise Sim acting as a log collector and analytics engine, and a static website that documents the architecture, attack scenarios, and dashboards. Everything you need is inside the code directory, the simulators, the website files, the installation guide, and the user manual. Before you start, make sure your environment meets the basic requirements. You need a Linux or Ubuntu-based VM or desktop with the Python 3 installed, at least one Splunk Enterprise instance with HTTP event collector enabled, and a modern web browser. The only Python dependency is the request library, which we install with pip. Step 1 is installing Python and a Python dependency. From a terminal, I confirm Python with Python 3 -- version. If Python isn't present, I install it with sudo apt update and sudo apt install python 3 -pip. Next, I install the request package using pip3 install requests. This is only external library the simulators need to send events into Splunk's HTTP event collector. Next, we configure Splunk after installing a Splunk Enterprise and starting the service. I log into Splunk's web and create an index called IoT devices. This is where all IOTShield telemetry will land. Then I enable HTTP Event Collector or HEC under Setting, Data Inputs, HTTP Event Collector. I turn HEC on and enable HTTPS and note the port in which in our lab is 8088. Finally, I create a new HEC token named something like IoT-shield-HEC, assign it to the IoT devices index, and copy the token value. This token and URL are what the 3 Python scripts use to authenticate into Splunk. Once Splunk is ready, we configure the 3 IoT simulators inside code-IoT IoT_devices. You'll see thermostat_simulator.py, camera_simulator.py, door_lock_simulator.py. At the top of each file, there's a configuration block with the 2 important constants, Splunk_HEC_URL, the HTTPS endpoint for HEC, usually HTTPS ///Splunk IP /8088 services collector event, and the Splunk _token, which is the HEC token we just created. I edit these values so all 3 simulators point to my Splunk instance and share the same token and index in IoT_devices. The rest of each script is device-specific logic. The thermostat generates temperature and humidity events. The camera generates motion alerts, and the door lock generates lock, unlock, and access attempts. Because everything is encoded as JSON and sent through HEC, Splunk ingests the data in real time and tags it with the source types like IoT::thermostat_ or IoT::camera or IoT::door lock. Now, to start the lab, I open 3 terminals, windows, and change into the IoT devices directory. In the first terminal I run Python 3 thermostat_simulator.py. In the second, I run Python 3 camera_simulator.py. And in the third, I run Python 3 doorlock_simulator.py. Each script prints the JSON payload, its standing plus confirmation that the event was accepted by Splunk, back in the Splunk search app, I can now search index dash quote unquote IoT underscore devices and watch events stream from all three devices. These events are what drive the dashboards and the 12 alerts searches shown elsewhere in the project. Now, the code package also includes the IOTShield website. Inside the website folder, we have the index.html, a single style sheet, and a 6 JavaScript module. To preview it locally, I run a simple HTTP server from the folder, for example, python 3-m http.server8080. Then I open the browser and go to http //127.0.0.1 8080 /. The site lets reviewers walk through the problem, the solution, the architecture diagram, and screenshots of key dashboards and attack scenarios without needing to navigate Splunk directly. Finally, a few quick notes on maintenance. Starting and stopping simulators, you have to use Control plus C in each terminal when you're done generating events. 2 would be monitoring Splunk storage periodically to check index sizes for IoT underscore devices and clear or roll data if you're running on a small VM. 3 will be updating the configuration if the Splunk IP, hex port, or token changes, or update the constants at the top of each simulator script. Refreshing dashboards and alerts, the detection searches can be tuned or cloned without changing the simulator code, which keeps the lab flexible for new experiments. Because everything is script driven and the website is fully static, there are no background services to maintain beyond Splunk. So that completes the IOTShield installation and maintenance walkthrough. With Splunk configured, the 3 simulators running, and the website online, you have a full reproducible lab for IoT threat simulation and SIM monitoring.